Okay, this is the Geometry Final Review for 2012, and I'm going to try to get all 50 problems done in a single video, and I'll put the different times that each problem starts in the comments below. Okay, problem 1 says, what is the height of a triangle whose base is 9.4 centimeters and whose area is 132.54 square centimeters? So let's draw that. We have a triangle. I drew an equilateral triangle. It doesn't have to be. It could be any type of triangle. It doesn't matter. And it says the base is 9.4 centimeters. It's asking for the height, which needs to go straight down and be perpendicular. And we know that the area is 132.54. So you want to use your formula for the area of a triangle, which is A equals 1/2 base times height. And we're just going to substitute in what we already know. We know the area is 132.54. The base is 9.4, and the height is what we're solving for. So the first thing I'm going to do is get rid of that 1/2 because I know that confuses a lot of you guys. And so 1/2 of 9.4 is 4.7, and I'm going to carry down the rest of the information. And then I just divide both sides by 4.7 to get the h by itself. And you get as your answer 28.2. And so that would be your answer to that problem. We're going to go back and reread the question, make sure we answered it. It says find the height, and so that's what we did, and we're all done. Okay, problem number 2. What is the circumference of a circle whose area is 121 pi square meters? So let's draw our circle. We're looking for the circumference, which is 2 pi r. Remember, circumference is the distance around. And they're giving us the area, which is 121 pi. Obviously, in order to find the circumference, you're going to need the radius. You can't find the circumference without that. And they didn't give us the radius, so we had to figure that out. We know that the area of a circle is pi r squared. And in this case, it's 121 pi, which they gave us. So right away, I see that the pi doesn't really matter because it's got it on both sides. That's irrelevant. And so we have r squared equals 121. The only thing that r could be is 11, because the only thing squared that equals 121 is 11 squared. So if our radius is 11, now we can plug it back in for the circumference. And so we get 22 pi. We're leaving things in terms of pi because unless they say otherwise, that's the easiest way to do it. So I did 2 times 11 and I got 22, and that's your answer to that question. Okay, problem 3, it says what is the area of the figure to the nearest tenth? And you see we have 4 figures. We have the 3 triangles and then the square. And so the first thing that I want you to notice that a bunch of you guys made a mistake with is that when we're finding the area of these triangles, you need the height, and they didn't give you the height. So don't start sticking 9s everywhere into your formulas because the height is not 9. So we have the triangle area is going to be 1/2 base times height, and so I'm saying we need the height in order to use that formula. And the area of the square is going to be base times height, which we can get that. That's no problem. So if we're looking at our triangles, and remember I said that we need the height, we see that we have a right triangle within the triangle here. And this distance right there would be half of the whole thing. And since you see that these are all the same, then this would be, all 3 sides are 9. So this would be 4.5 because it's half of 9. So we're going to use our Pythagorean theorem, which is a squared plus b squared equals c squared. So I'm going to use 4.5 as my a. We're trying to find b, that's the height. And then our c is 9. So 4.5 squared is 20.25, and 9 squared is 81. And if we subtract 20.25 from 81, we get 60.75. So we have this. So we have b squared equals 60.75. And then our last step, of course, is to take the square root so that we can get b by itself. And we would get 7.79. So that means that the height of this triangle is 7.79 centimeters. So now, once we have that, we're actually ready to plug everything into these formulas. So for our triangles, we have 1/2, the base is 9 because they're equilateral triangles, and then the height would be this number that we just calculated. And so if we actually multiply that all out, each triangle has an area of 35.07 square centimeters. And there are 3 triangles, so I'm going to multiply this by 3. And I get 105.22. So those are triangles. I'm going to underline that. And then if we do our square, the sides are all 9 because the triangles have a base of 9, so that has to be the same as the square. So we have 9 times 9 equals 81. And we're just going to add these two numbers together, and we get as our total area 186.22, and that's our answer. There you go. Okay, problem number 4. This one is actually pretty straightforward. It just seems kind of tricky. We have essentially a subtraction problem. So we're going to be finding the area of this rectangle, and then we're subtracting out the circle. And the important thing that you want to notice is that the circle goes from the top here down to the bottom of this rectangle, which means the diameter is this 14. They're the same length. And so that means our radius would be 7. So that's important that you notice where the circle touches. So we have area of the rectangle is just going to be base times height, which is 14. That doesn't fit. 14 times 21, which equals 294. So we'll keep that to the side. And then we find our area of the circle, which is going to be pi r squared. So it's pi times 7 squared. And I'm not going to keep this in terms of pi because I'm subtracting it from a rectangle. So we would have a weird long expression if I didn't get a decimal for it. So in this one case, I'm actually going to get the decimal, which is 153.94. And so now we just take these two things and subtract them. And so I'll write it out. 294 minus 153.94. That equals 140.06, which would be your answer. And so that's all you have to do on that one. Okay, problem number 5. It's asking for the perimeter of the rhombus, and we need the area of the rhombus to be 96 square meters. So first of all, you may not be super familiar with this formula, but the area of a rhombus is 1/2 d1 d2, and the d means diagonal. So it's saying half of the first diagonal times half of the second diagonal. And so these are your diagonals. Here's diagonal 1, and then this other one is diagonal 2. So we need to figure out what diagonal 2 is, and then we're eventually going to use that to get the actual perimeter of this figure. So if the area is 96, let's go ahead and write that out. I don't know what pen color I want. So we have 96 equals 1/2 d1 they give us, which is 12, and we need d2. So I'm going to go ahead and get rid of the 1/2. 1/2 of 12 is 6, and then if I divide both sides by 6, I get 16. So that means the diagonal 2 is 16 units long. So I'm going to write that here. Okay, and so since we want the perimeter, we need to know how long this side is. And remember that for a rhombus, all four sides are the same. It's just that the angles are not right angles like a square would be. So if we get one side, we know what all four sides are. So if you look here, this is actually a right angle. This distance here that I'm coloring in would be 6. And the reason is that the entire diagonal is 12, and so since we're only going halfway, it would be 6. And similarly, this diagonal here would be 8 because it's half of the 16, which is the other diagonal. So now you should hopefully recognize that we have a right triangle and we can use the Pythagorean theorem. And we're going to be solving for the hypotenuse because the side of the rhombus is across from the right angle. So we have 6 squared plus 8 squared equals c squared. 6 squared is 36, 8 squared is 64. These two add up to give us 100. And so that means that c has to equal 10. So if that's 10, then since it's a rhombus, this is 10, that's 10, that's 10. And that means that our perimeter is 10 times 4, because there's 4 sides. And so it would be 40. So your answer is D. Notice that answer B is the other diagonal, is this answer we got. Answer B is the halfway that we got earlier. Answer C is only one of the sides. So all 3 other answer choices are them trying to trick you into getting excited about finding one of the answer choices, and you don't realize that you're actually not done with the problem. So be sure that you always go back and reread the question to make sure that you finished. In this case, it's asking for perimeter, so you need to go all the way through and finish getting the perimeter before you answer. Okay, here's problem number 6. And we have a trapezoid, and we're looking for B, which is over here. Okay. And so I'm going to forget about B right now, and I'm just going to think about this whole side, because we don't even know this side yet. Okay, so the formula that we're going to use for a trapezoid is 1/2 of the 2 bases added together, and we multiply that by height. So they tell us that the area is going to be 138, so I'm going to substitute that in. 1/2, B1 is 9, so remember that this is B1, and down here would be B2, or the top one could be B2 and the bottom could be B1. It doesn't matter which is which, as long as you know that those 2 sides are your bases. So we don't know B2 yet. And then the height of our trapezoid, of course, is 12. A lot of you guys get confused here. You don't know what you're supposed to do first. I always think it's easier to get rid of the fractions first. So this 1/2, we can go ahead and multiply with that 12. Remember, you can multiply in any order you want. So 1/2 of 12 is 6. And so now that's just a little bit more straightforward. Before we can start working with the 9 inside the parentheses, we need to get rid of the 6. And since it's being multiplied by that, we're going to divide both sides by 6. And so we get 23 on this side. Okay, and now I can subtract 9 from both sides. And I'm going to get 14 equals V2. So now we know that this whole side here is 14. You see that this dotted line goes up here to the 9, right? So that means that this right here would have to be 9. And so the missing part to get that B would be 14, the whole base, minus the 9 that's already taken up. And so we would get 5. Okay, and we're going to go back, make sure we read it right. What's the value for B? And we actually did find that value. And so we're done, and that's our answer. Okay, problem number 7. It says, what measurement makes a circle with an area of 64 pi yards squared? So we have area equals 64 pi. And you notice that the answer choices are either radius or diameter. So we want to think about that, which one it is that we're calculating. So we know that the area is pi r squared, And you see that both sides have a pi, and so that doesn't really contribute anything, so I'm just going to get rid of it. And at this point, the only thing that the r could be to make this work is 8, because 8 squared is 64. So our radius now we know. And if we look through our answer choices, we see here is radius equals 8. Be careful, you can see how they might have tricked you with G by changing this letter to D. And then the other two answer choices are if you used 2 pi r for circumference instead of the right formula, which is pi r squared. Okay, so problem 8 gives us a triangle. And I think the thing that really confuses you guys with problem 8 is this little section right here. And the important thing to recognize is that this extra little triangle here is not actually part of the triangle that they're talking about. So the only triangle that you're trying to figure out is this right here. And it's asking for the base, which is just that part up to here. It doesn't go to where the dotted line is. So the only reason that they have the dotted line stuff there is just to show you like where the height is and how to figure out the height. And really, I think it doesn't do anything but confuse you guys. So you need to overlook that little extra bit. So it tells us that the area is 29.16 and the altitude is 5.4 inches. So that's this height, because remember it has to be perpendicular with the bottom. So that's why they have it drawn there. There's not really anywhere else in the triangle that's straight up and down that's already drawn. So that's why they added that extra bit there. So we're just going to use the formula. A equals 1/2 base times height. They give us the area, which is 29.16. We're looking for the base, and then they give us the height, which is 5.4. So just like I've said before, I think the easiest way to start these problems is to get rid of the 1/2. So we're going to do 1/2 times 5.4 because we can multiply in any order. And you get 2.7b. Just carry the b down. And then the 29.16 gets carried down. And then you just need to get rid of the 2.7. So you're going to divide both sides by 2.7. And you're going to get as your answer 10.8, and that equals the base. So we make sure that we reread the question. It says, what is the length of the base? And so that's what we got, so that's our answer, and we're all set. Okay, so here it's asking for the area of the parallelogram. Once again, it's got this confusing little triangle thing on the side, and this is just to try to tell you what the height is. You're only really concerned with this part of it. Okay, and so the formula that we're going to use for parallelogram is the same as rectangle. It's just base times height. The thing is that the base and the height have to be perpendicular. So that means that the 15 that we see over here is not the height because it's not straight up and down. 25 is the base, but 15 is not the height. So in order to get the height, we're going to use this little triangle thing drawn out to the side here. So I know that this side is going to be 15 just like the other side. And now I can use the Pythagorean theorem. So we have 15 squared equals 9 squared plus something squared. So the height that we're trying to find is our b. So 15 squared is 225. 9 squared is 81. And then we add b squared. Oops. So we're going to do 225 minus 81 so that we can get rid of the 81 on both sides. On the right side, we're left with b squared. On the left side, we have 144. And so once we take the square root, we get b equals 12. So that means that this right here is 12. And so now we are ready to plug things in. So we have area equals the base, which we said is 25, and the height, which is 12, and when you multiply those, you get 300, and that's your answer. Okay, problem 10, we're going to have to go ahead and draw out. It says the perimeter of a rhombus is 40 centimeters and the length of one diagonal is 12 centimeters. Find the area of the rhombus. So I'm going to draw it. Okay, it says the perimeter is 40. Since it's a rhombus, all of these sides are the same, so they're all going to be 10. and then one of the diagonals is 12, and we're trying to find the area. Some of you may recognize that we've already done this exact same rhombus a couple of problems ago, but we found the perimeter and they gave us the area. If you see that, great job, you're paying attention, but we'll go ahead and work through the problem anyway, just so that you know how to do it both directions, okay? So the first thing we want to do is try to figure out what the other diagonal is, because remember that our formula is 1/2 of the two diagonals multiplied by each other. And so far we have the 12, but we don't have the other one, so we're missing that. Okay, so here would be a right angle. I know that just this distance right here is going to be 6 because it's half of the whole diagonal, and I need to know what this right here is. So I'm going to set up the Pythagorean theorem, and a squared is what I'm looking for, plus 6 squared equals 10 squared, because the hypotenuse is 10. So we get a squared, plus 36 equals 100. I'm going to come over here. I'm subtracting 36 from both sides. And so when I do that, I get 64, which means a is 8. So if this right here is 8, then it means that whole diagonal has to be 16. And so that's what I plug in there. And then if you actually multiply that out, you get 96 as our area, which is exactly what we started out with in the other problem. And so that's how that's done, is with the right triangle. Okay, problem 11, we have a kite, which is the one that looks like this. So these two are the same, and then these two are the same. And it has an area of 3x cubed y cubed, and one of the diagonals is, I'm going to say it's this one, one of the diagonals is 2x squared y. So we use the same formula for kite as we did for the rhombus, which is 1/2 d1 d2, and they give us the area is 3x cubed y cubed equals 1/2. The d1 that we have already is 2x squared y, and we're trying to find the other diagonal. I ran out of screen. Okay, so the first thing I want to do is just get rid of this 1/2 and this 2, just to make my life a little bit easier. So when I do that, 1/2 of 2 is just 1. So we end up with x squared y and then times something. So what I want to think about is all the stuff that's missing in order to get to this answer over here. First of all, I don't have a 3, so I need that. Here I have 3 x's. On this side I only have 2, so I'm going to need at least 1 x, exactly 1 x. And on this side I have 3 y's. On this side I only have 1, so I'm going to need 2 y's. So that would be my answer, is 3xy squared. The other way you could do it is if we go back to this step. So we have 3x cubed y cubed equals x squared y, and we're trying to get whatever is in this parentheses by itself. We can divide both sides by x squared y, and then that way you can cancel stuff out and you get the same answer that way. I think it's easier though just to ask yourself, like, what am I missing, and then write it on there. Okay, problem 12, it says we have rhombus ABCD. The length of diagonal BD is 2/3 of AC. So I'm going to just go ahead and call AC X, just to make my life a little bit easier. And so that means that BD is 2/3 of that, so it's 2/3 X. And we're going to use the same formula we've been using for these problems, which is 1/2 d1 d2. So we have 1/2. My first diagonal will be the x, and then the other diagonal is that 2/3 x. And it tells us that the area is 75. So we have 75 equals, I'm going to put the numbers together, 1/2 times 2/3, and then I have the 2 x's. So I just rearranged things. 1/2 and 2/3, these 2's cancel out, and we end up with 1/3. and then x times x is x squared. So now, in order to get rid of that 1/3, I need to multiply both sides by 3. So this is times 3, and this is times 3. So 3 times 75 is 225. And the 3 and the 1/3 cancel out, and we end up with x squared there. And then if we take the square root of both sides, we get x. And so now we know that x is equal to 15, but the question is asking us for BD, which is the 2/3 x, and so I need to substitute that in. So we have 2/3 x, we said was 15, and 2/3 of 15 is 10. So your answer would be 10. Okay, problem 13, which term does not describe the figure? Okay, so let's look at A, concave. Well, it has a cave here. You could stick a person in there, and if it were raining, they wouldn't get wet. So that's still definitely concave. So that one is not the right answer because we're looking for the wrong one. Hexagon has 6 sides, so we have 1, 2, 3, 4, 5, 6. So it is a hexagon. That's not the answer. Polygon, remember, is just straight sides, no openings, nothing round. I mean, we've basically got a polygon. There's no reason this wouldn't be a polygon. So that's out. And the last one is regular. And so remember, regular has to be same angles, same sides. And we see here that these sides are not the same as that. And also this angle is not the same as any of these angles. All of these angles are different. And so it would have to be D. It's not regular, it's irregular. Okay, problem 14. What is the sum of the measures of the interior angles of a 5-sided convex polygon? So let's draw the 5-sided convex polygon first. 1, 2, 3, 4, 5. Convex just means there's not any caves in there. It's probably what you would have drawn anyway if I had told you to draw a 5-sided polygon. So if you remember, what we do is we start at one vertex, it doesn't matter which one, and I'm going to draw a diagonal to all of the other vertices that I can. So I can only draw 2 diagonals. Okay. And so now we know that this triangle here has 180 degrees, this one has 180, and this one has 180. And so the whole pentagon itself has 180 times 3 degrees, which is 540. And so that would be your answer. So you just split it into triangles and then count how many triangles there are, and that's it. Okay, problem 15. What is the value of A? These are all exterior angles, so remember that the exterior angles, no matter how many there are, they always have to add up to 360. So all you need to do is take 360, and then we're going to subtract all of the angles. I'm subtracting 127, 71, and 102. And if you do that in the calculator, you get 60 degrees. And that's your answer for A. That's the missing angle. Okay, problem 16, it says WXYZ is a parallelogram, which is, or I guess how big is measure of angle W. And so really easy, if you see that it's multiple choice, if this is 112 degrees, this obviously can't be because they're not the same. This one is obtuse and this one's acute, and you only have 2 answer choices, so clearly it would have to be 68 because it's not going to be the 112. You may not always have an answer choice though, so the correct way to do this is that you have to know that they're supplementary, and so they have to add up to 180. So 180 minus 112 would be 68, which is your answer. Okay, and then problem 17 is using the same picture as problem 16, and it says WXYZ is a parallelogram. What's the value of X? And so in this case, we're going to be using these 2 expressions here. And since it's a parallelogram, they both have to be congruent. So I'm going to write 8x plus 12 equals 68. In order to get the x by itself, I'm going to start by subtracting 12 from both sides. So we have 8x equals 56, and then we just divide both sides by 8, and we get x equals 7, and the question is asking for the value of x, which is what we found, and so we're done with that problem. Okay, problem 18, it says which must be a parallelogram. Well, the first one, figure 1, could be a parallelogram, but you don't know anything about these two sides, and they could be completely different, but just very, very small difference to where your eye wouldn't notice it. If we look at figure 2, though, it's basically saying that both of these diagonals have been bisected, because that's both 1 on each side, and then this has 2 marks on each side. So this one has to be the parallelogram because the diagonals are being bisected. Okay, problem 19, PQRS is a rectangle. PR is 26, and they want to know what the value of x is. So PR here is 26. And so the big key here that you want to know is that the diagonals are congruent. So 26 equals 2x, which is that other diagonal from S to Q. And so we just divide both sides by 2, and we get 13. It's asking for x, we found x, and so that's our answer, and we're done with that problem. Okay, so problem 20 says, what is the measure of angle F in the isosceles trapezoid? So isosceles means that these two sides are the same. And since it's a trapezoid, we know that these two sides have to be parallel. Okay, so we've got two congruent sides and two parallel sides. So because it's isosceles, these two angles have to be the same, just like these two are going to end up being the same. And what you want to think about as you're doing this problem is that because these two sides are parallel here, this one and this one, and we have this transversal going through it, these two angles would be same side interior. So we're talking about a situation like those with those two angles, and so they have to be supplementary. Same side, anything is always going to be supplementary. So that leaves us with 180 minus 101, which is going to be 79 degrees. And so that's this angle right here, 79 degrees. That's our answer. It's asking for F, and the one I pointed to is F. Okay, problem 21, it says in trapezoid PQRS, what is the length of mid-segment XY, which is this one right here. And so the only thing you need to know for this problem is that the two bases are averaged together to give us the mid-segment. So basically, the length of this guy is the average of these two. And so we're going to do XY equals 34 plus 62, and we divide that by 2. And when you do that, you get 48. Remember, when you're doing problems like these, you need to add the 64 or the 34 and the 62 first before you divide by 2. Don't try to type it in the calculator like this, because then you're only dividing the 62 by 2. You'd want to use parentheses, or just do the 34 plus 62, hit enter, and then divide that number by 2. So our answer is 48. Okay, problem 22, it says in parallelogram DEFG, what is the length of EG? So we're trying to figure out this guy right here. We notice that we've got half of it, but we don't know what x is, so we need to figure that out. And you see that these two opposite sides right here have stuff marked on them. And the opposite sides of a parallelogram would have to be equal or congruent. So I'm going to go ahead and set those equal to each other. So I put them equal. We're going to solve. At this point, it doesn't matter which thing you move first. I'm going to move the 3x over, but you could move something else over first if you wanted. So 5x minus 3x is 2x. Carry everything else down. And then I'm going to add 5 to both sides to get the x by itself. So you end up with 2x equals 14. And then the last step is you just divide by 2. So you get x equals 7. Okay, so now we don't want to stop there because it's asking for EG. So we're going to do 4 times 7. I'm plugging it into this right here. Minus 3. So we have 28 minus 3 equals 25. So this right here is 25. That means that this would have to be 25. And so the whole distance would be a grand total of 50. Okay, so problem 23 says in kite UVWX, measure of angle XUV, so this angle right here is 84 degrees, and measure of angle WVX right here is 68 degrees. And they want to know the measure of angle VWX, which is this whole angle here. Okay, so what I need to do first is figure out what these two angles are, which are both going to be the same because that's an isosceles triangle. So we know that, we'll say this, we'll call this x, so these would both be x. So x plus the last angle of 84 equals 180. So in case that's not making sense, I'm going to draw that triangle out here to the side. So this is 84. We know that these two have to be the same because it's isosceles. And so those three angles have to add up to 180 degrees. So I'm going to go ahead and solve that. This is 2x's. And then we're going to subtract 84 from both sides. So we get 2x equals 96. And then we just divide both sides by 2. So we get x equals 48. So these angles are both 48. Okay, so since this right here is 68 and this is 48, I can find that whole angle, which this whole thing right here would be 116. So I added 48 and 68 and I got 116. So I'm going to clean this up a little bit because it's getting pretty crowded. So this is 116. This is also going to be 116, and then we're looking for this angle down here. The four angles of a quadrilateral are going to have to add up to 360. So I'm just going to subtract the 3 that we have. We've got that 84 and then 216s that we're subtracting off of there. And so when you actually subtract those, you end up getting 44 degrees, and so that would be your answer for W. Okay, so problem number 24, it says an isosceles trapezoid DEFG, DF, which is this one here, equals x squared minus 3x, and EG, which is this one here, is negative 5x plus 15. Since it's an isosceles trapezoid, these two diagonals have to be congruent to each other. So I'm going to set them equal. Whoops. So we have x squared minus 3x equals negative 5x plus 15. And I'm going to actually get it so that this side here comes out to 0, and I'll show you why that is helpful in just a second. So I'm going to add 5x to both sides first. So you get x squared plus 2x equals 15, and then I'm going to subtract 15 from both sides. Notice that these two things are not like terms with the 15 because these two have x's and the 15 doesn't. So everything just has to stay separate. We have x squared plus 2x minus 15, and you can't squish it together any more than that. So now here's where we do that factoring thing that I've been trying to teach you guys lately. So the first term is going to be x because there's nothing in front of the x squared value. And then for the second term, we need two numbers that multiply to give me negative 15 and add to give me 2. So let's think of all the numbers that we can multiply to get negative 15. And there's our set. And out of all these numbers, the two that actually add up to give us a positive 2 are these two. So those are the ones that I'm going to stick in here. And then if you think about this, we have this thing times this thing equals 0. So the only way to get 0 is if either this one is 0 or this one is 0. But you can't multiply things and get 0 unless one of them is 0. So let's try both of those, and I need to clear some space off here. So let's say that it's the left side that equals 0. So this x minus 3 term. That would mean that x equals 3. So we'll just kind of put that on the side burner. Let's say hypothetically instead that it's this one, x equals 5, or x plus 5. So in this case, x would equal negative 5. So we need to decide which one of those is right, because they're not both right. Okay, so I'm going to clear off more space here so I can write more. Okay, so we have, let's say that x equals 3. We'll take that. So does x equal 3? We're trying to figure that out. So if we plug those into the two diagonals that they give us, the first diagonal was negative 5 times x plus 15. So I've just substituted into that x. And that gives us negative 15 plus 15, which equals 0. So that would mean that this diagonal here is 0 units long. That makes no sense because clearly it's not a black hole or a singularity or anything weird like that. It's a trapezoid. So there's no way that EG could possibly be 0. So that means that this doesn't make any sense. Oops. X can't equal 3. Well, let's try the x equals negative 5 and see if that works. Oops, that's not how you spell does. So does x equal negative 5? Well, let's find out and plug it in. So we're going to do the same thing. I'm going to plug in for x. Here we get positive 25 because it's negative times negative. And when you add those, you get 40. Well, 40 makes, that could work, right? There's nothing wrong with 40. Let's try the other one. So now we have here x squared minus 3x. So negative 5 squared, put it in parentheses, minus 3, and then negative 5 also in parentheses. So negative 5 times negative 5 is positive 25. Oops. Negative 3 times negative 5 is positive 15. And we get 40, which shouldn't surprise us because we meant for them to be equal. And so that makes sense. So x equals 3 doesn't make any sense. X equals negative 5 does make sense. The question is asking us to find the value of x, which would be negative 5 for this problem. Okay, problem 25 says RSTU is a rhombus. Measure of angle SRU, so this whole angle here, is 112 degrees. And they want to know what TRU, so just this part right here. Okay, well, TRU is going to be half because this line is splitting these angles in half. And so half of 112 is 56. And so that's our answer. That's all we have to do. It's just half of the 112. Okay. What is this problem 26? And it says, what is the lateral area of the rectangular prism? And the formula that we're going to use is, so lateral surface area is capital PH. Remember, the capital P is the perimeter of the base. And in this case, here's our base. And where I'm drawing is the perimeter. So it'd be 12 plus 8 plus 12 plus 8. So if we actually do that out, that's 20, that's 20, and so our whole perimeter is 40. So we plug 40 into that P. The H they give us, it's that 24 there. And so we just need to multiply 40 times 24, and we get 960, and that is all we have to do. Okay, problem 27. What is the surface area of the cylinder? Remember that if they don't give us like a specification, lateral or total, then your default would be total. Okay, so we're looking for the total surface area, and the total surface area formula is going to be pi r h. Sorry, that's 2 pi r h. 2 pi r h is our formula. So we have 2 pi, the radius they give us is 3, the height they give us is 9. We're going to do the smart thing here and leave this in terms of pi. So I'm going to do 2 times 3 times 9 in the calculator, and I get 54, and then the pi just hangs out on the side, and that's our answer. Done. Okay, problem 28 says, what is the volume of the right cylinder? Remember, right cylinder means it's straight up and down. It's not leaning over to the side. That would be called oblique. And so the volume formula is pi r squared h. We just plug stuff in. The radius is 4, and the height is 12. We're leaving it in terms of pi, so there's no need to type the pi in the calculator. So if we do 4 squared times 12, we get 192. And so if we write it in the correct order, we have 192 pi. And that's our answer for the volume. All done. Okay, problem 29 is kind of a long, ugly problem. What I'm going to do is draw all of the surfaces separately, and then if we find all of the individual surfaces, we're all set, and that's maybe the most conceptual way to do this. So I'm going to draw this guy first. So we have him here. He's 9 units across, and this 7 tells us that he's 7 units tall. Okay, and so we have this one here in the front, and then we also have, it's really hard to see it, but it'd be one in the back. That would be the same thing, so there's 2 of these. Okay, let's clean off our picture here. Okay, so now I'm going to do the side here. So it's another rectangle-y thing. So down here is 7.5, and then this is 7. So that's that guy, and then we see that we have another identical one over here on the side. So there's going to be 2 of those. Okay, so now let's get rid of that mess, and we have more here. We have the bottom guy. Okay, so this bottom part here is 9, and then this part here would be 7.5, and there's only one of those because if you look at the top, we've got this like hole here, so that's going to be a separate issue. Okay, so far we have everything on the bottom one, on this bottom prism, except for the top, so we're going to do that now. So we have a square-ish thing, which is actually a rectangle. And then here is this. And ants can't walk there because there's a box in the way, and so we would end up having to subtract that out. So if we try to figure out these dimensions, we have 7.5 here, and then this would be 9. So it's just like this one here. And then as for this little box in the middle, it has the same dimensions as the top of that same box. So it'd be 4 by 4. Okay? So now we've got the whole bottom one taken care of completely. So now we're going to look at the top. Here's this little bitty square up here at the top. So that's 4 by 4. And then we have this right here. And so it would be 8 units tall and 4 units across. And since these are all 4, there's just 4 of these. So basically this guy right here, this guy here, and then the back and the other side. Okay, so we've actually gotten everything, I believe. We have all of the sides along the bottom here. we took care of this part with the missing thing in the middle. We've got all four of these sides here, and then we have the top right here. So these are all our parts of our composite figure. We just need to find the areas of each of them. So on this first one at the top left, the area is going to be 63, but there's two of them, so that's going to give us a total of 126. So that's for this guy. The next one is 7 times 7.5 is 52.5, and there's two of those, so we're getting a total of 105 from that. Over here we have 9 times 7.5, which is 67.5, and there's only one of those, so I just leave it there. Down here we know that the big one is going to be 67.5, and then we're subtracting this little piece here, so it'd be 4 by 4 is 16. So 67.5 minus 16 is 51.5, and there's only one of those, so that's all we've got there. This little square here is 4 by 4, so that's 16. There's only one, so that's there. And then this last one, 8 times 4 is 32. There's four of them, and so we get a total of 128 from that guy. And so our total area is just going to be all of these circled numbers added together. I'm going to run out of space. Okay, so if we add those all up together, we get as our grand total should get 494. Hopefully I didn't make a mistake in that problem. If I made a mistake, come and tell me on Tuesday or Wednesday or Thursday, and I'll give you extra credit for it. Okay, problem 30. Describe the three-dimensional figure that can be made from the net. Well, these little guys would fold down, and this would connect them, and we have a cylinder. And so this would be a cylinder. Okay, problem 31. Find the lateral and total surface areas of the figure. I'm just going to use the formula for this one. So for the lateral surface area, our formula is capital PH. Remember, the capital P is the perimeter. And so this perimeter is down here. It's going to be 6 plus 4 plus 6 plus 4. So we have here 10 and 10. So we get a perimeter of 20. And then the height they give us is 12. And so 20 times 12 gives us a total of 240 for the lateral surface area. Okay, and then for the total surface area, we already have the pH. That's what we just figured out. Oops, plus 2b, sorry. And remember, the capital B stands for area of the base. And so the area of the base is going to be 6 times 4, which is 24. And we would multiply that by 2. So if we put that all in, we get a total of 288, and that's our total surface area. Okay, problem 32 says give the lateral and surface areas of the figure. Give your answers in terms of pi, just like we normally would. So the lateral surface area is going to be 2 pi RH. So we just plug in 2 pi r is 4, and the height they give us is 12. Since we're leaving it in terms of pi, I'm not going to put the pi in the calculator. So 2 times 4 times 12 would be 96, and then there's the pi. And that would be your answer in terms of pi for lateral surface area. And then for total surface area, we have this formula. We've already done 2 pi RH, that's 96 pi. And then 2 pi r squared would be this. So we have 16 times 2 is 32 pi. And we're just going to add the 96 and the 32. We get a total of 128, and that pi just tags along. So that's our total surface area in terms of pi. Okay, problem 33 says find the lateral and total surface areas of the regular pyramid. So our lateral surface area is going to be 1/2 PL, curvy L. The capital P is the perimeter of the base, and the L is the slant height. So here our perimeter we can get is 6 plus 6 plus 6 plus 6, which would be 24. So I'm going to go ahead and write that in. And then our slant height is, remember, it's the height on the outside. So they actually have it marked here, right here, and that's 8. So it's from the tip to the outside edge, not to the center. Oh gosh. So that's 8. So 1/2 times 24 is 12. Well, yeah, 12, but then I wrote 24. 12 times 8. And if we do 12 times 8, we get 96. And so that's your lateral surface area. And then to get our total surface area is going to be this formula. We've already done the 1/2 PL, that's 96. The capital B stands for area of the base. In this case, it's 6 and 6, so we get 36. 6 times 6 is 36. And if you add those together, you get a grand total of 132. And so that's your total surface area. Okay, problem 34. Find the lateral and total surface areas of the right cone in terms of pi. Remember, right cone just means that it's straight up and down. It's not slanted or anything like that. And so we have lateral surface area equals pi RL. And L is your slant height. So in this case, our R is 5. And then on this particular picture, that slant height's a little confusing. This 13 here is the slant height. It seems like maybe they meant this part, but they don't. That's actually the slant height. So you don't have to do anything fancy with that. So 5 times 13 is 65, and we just write it in the correct order. And there's our lateral surface area. And then to get the total surface area, we have pi RL plus pi R squared. We've already done the pi RL, it's 65 pi. And then pi R squared is going to be pi 5 squared. So we have 65 pi plus 25 pi. So 65 plus 25 is 90. So we get a total of 90 pi. And that's our total surface area. Problem 35 says to find the volume of the pyramid, and our volume formula is 1/3 BH. Remember, the B does not stand for base, it stands for area of the base. And so this is my base. The area of it would just be 6 times 6, which is 36. So V equals 1/3 times 36, and then my height is 7, it's marked on there. So if we multiply those all out, we end up with 84, and that's our volume. Okay, problem 36 says to find the volume of the cone in terms of pi. So again, our formula is this. I think in your formula chart it might be marked as this. I don't remember. It's the same thing. So basically the capital B is the area of the base, and so in this case our base is a circle, and so the area of a circle is pi R squared. Which is how I got that. So it's the same thing. So let's go ahead and plug stuff in. The R is going to be 10, it's marked on there. And then the H is 42, it's marked on there too. And so if we multiply those all out, we get a total of 1400. And I did not put the pi in the calculator, I just did 1/3, 10 squared, and 42. And so we end up with 1400 pi as our volume. Okay, problem 37 says to find the volume of the cylinder in terms of pi. And so we have volume equals area of the base times height. Your formula chart may have pi r squared h. It's the same thing because in this case, to get that capital B, the area of the base, that's a circle, and so the area of the circle would be pi r squared, which is where that comes from. So we're going to go ahead and just plug everything in. I'm using pi, my radius is 3, and then the height would be 9. And so we end up with pi, and then 3 squared is 9 times 9 from that one. And so we end up with 81 pi. So it's in terms of pi, and that's the volume. Okay, 38 says find the volume of the sphere in terms of pi. Some of you guys get caught up because we haven't done a whole lot of spheres, but it's just a formula like anything else. And that formula is 4/3 pi r cubed. So we just plug stuff in. My radius is 6. So you can use your calculator to do that. We're not going to put the pi in the calculator. It's just like any other problem. So we end up getting 288 pi. So I did 4/3 and 6 cubed, and I get 288 pi. And that's that answer. Okay. Number 39 is asking for the surface area. So once again, it's just a formula. So it's 4 pi r squared. Some of you guys asked me if they wanted total or lateral surface area. Remember, lateral doesn't make any sense for a sphere because the sphere doesn't have bases. It's round all the way around. So this is your only choice, is total. So we have 4 pi 6 squared. Again, leave the pi alone. We don't want to type that in the calculator. So if we do 4 times 6 squared, you get 144, and the pi just goes along for the ride, and there's your answer. Okay, problem number 40. Find the lateral and surface area of the regular triangular prism. So regular triangular prism means that these are all going to be the same. They're all 9. Okay, and it says round to the nearest tenth if necessary. So the formula that we're going to use for lateral surface area would be pH. And so I need to find the perimeter of the triangle and then multiplied by the height. In this case, the perimeter is going to be 9 plus 9 plus 9, since there's only 3 sides, so that's 27. And I'm multiplying that by the height, which is 14. And so I end up getting 378 as my lateral surface area. Okay. For my total surface area, it's pH plus 2b. So we've already got the pH, that was 378. And we need to find the capital B, which is the area of the base. That's a little bit trickier. So our base is a triangle, so that means we're going to use this formula, 1/2 base times height, to get the area of it. And the problem is that we don't have the height of this triangle. So that's what we need. You see that I've basically just drawn a right triangle. So this is 9. We don't know this. And this distance down there would be half of 9, which is 4.5. So I'm going to use the Pythagorean theorem. And so we have x squared, that's what we're looking for, plus 4.5 squared equals 9 squared. So x squared equals 20.25 equals 81. And I totally did not mean to put an equals sign there. That's a plus sign. And then if I subtract 20.25 from both sides, we get x squared, I'm going to write it here, equals 60.75. And then if we take the square root of both sides, x equals 7.79. And some of you guys have already noticed that we already did that particular triangle with the Pythagorean theorem before, so hopefully you recognized it and just went straight to it. But that means that our height is now 7.79. Okay, so now we can go back to our area of the base part that we're trying to figure out here. So we have 1/2, the base is 9, the height is 7.79, and if you multiply that out, you end up getting 35.06 if we round, and that's what needs to go in here. And so if we go ahead and just multiply that out, we get 448, 0.11, and that's our total surface area. And it says to round to the nearest tenth, so it should have been 448.1. I didn't need the second one. So that was kind of a long problem. Watch it again if you didn't catch it all. Okay, problem number 41. It says find the volume of the regular hexagonal prism, if necessary, round to the nearest tenth. This one is kind of messy. So volume is going to be capital BH, where the capital B stands for the area of the base. We have the height. It's marked on there. It's 15. We don't have the area of the base. We need to figure that out. So we have hexagon. I'm going to draw it out here. Okay, and it's saying that this is 8. If you guys remember back a long time ago, we drew triangles here, and then we had to figure out this. So the area of this polygon is going to be 1/2 AP. A stands for apothem. P stands for perimeter. This thing here that I have this arrow to, that's our apothem that we need to figure out. Okay? So the first thing we want to do is figure out how many degrees this angle right here is. Since there's 8, let me erase some of this. Hold on. Okay, so there would actually be 8 triangles all the way around this thing, right? And the whole thing has to have 360 degrees. So if I do 360 divided by 8, I get 45. So that means that each of these angles is going to be 45 degrees. Okay, so that's great. But we don't want the whole triangle. We're actually, remember, dropping down a line here. And so that means that this angle that we're interested in is half of 45, which is 22 point, oops, that was supposed to be a 5. 22.5. Okay, so what we end up with in here, let's draw this again. We have this triangle, and that's 22.5 degrees. And we're trying to find this side here. This right here is 4 because the whole entire side is 8, but I'm only interested in half of it. And so we need to use our trig stuff. So tangent of the angle, which is 22.5, equals opposite. So opposite from the angle is the 4. Over adjacent is x. So if you don't remember this, it's SOHCAHTOA. And I'm doing tangent, which is opposite over adjacent. Okay, so what we're going to end up typing in the calculator, remember we switch the tangent and the x. So if I divide that in the calculator, what I get is, let me do it real quick, x equals 9.66. Okay, remember before you type this in the calculator, you just need to be sure that you're in degrees and not radians. So you hit mode and go to degrees. So that means that this right here is 9.66, which is our apothem, and so we can actually plug that in now. So we have 9.66. The perimeter, this whole thing is 8, 8, 8, 8, 8, 8. So it's 8 times 6, which is 48. And if we multiply that out, we get as our answer for the area 231.76. So the area of this hexagon right here is 231.76. Okay, so we go back to our original problem. It's asking us for volume. So I'm going to plug in 231.76. My height, they gave us, that one's not a problem. And so we end up getting as our answer 3,476.5 if we're rounding to the nearest tenth. And that's our volume. So that problem was a pretty long problem. It gets kind of complicated, and we really didn't spend that much time doing it over in class. So if you have trouble with this, watch it again, and if you're still not getting it, just make sure you pull me aside at some point on Tuesday and get help for it. Okay? Or you could post a message here and I'll reply to the video comments. Okay, problem number 42. It says if a polyhedron has 10 vertices and 7 faces, how many edges does it have? And so polyhedron, remember, is like a three-dimensional solid. It's like a polygon but 3D. So a cube would be a polyhedron. Or a soccer ball, remember, was a truncated icosahedron. Or I hope that's the right what I'm saying. So anyway, what this question is getting at is the Euler characteristic, which is this formula. And we spent a couple days looking at it. I don't know if you guys remember it, but you'll have whatever formulas you need for the test. So you don't need to memorize this formula, okay? So V stands for vertices, E stands for edges, and F stands for faces. So in this case, they give us 10 vertices. We don't know the edges, and it has 7 faces. Okay, so 10 and 7 combine to give us 17. I'm going to subtract 17 from both sides. And so E is going to be positive 15. So that means that if you have that icosahedron, and you have 10 vertices and 7 faces, the vertices are the corners. So there's 10 of these and 7 of these, and so the number of edges that you have is 15. So that's what it's saying. Okay, problem 43 should be pretty straightforward. Remember that when you're looking at the front view, this is like the ground down here, and this is the sky. Same thing with the side. This is the ground, and this is the sky. And then if you're looking down from the top, the ground is underneath, like you're looking straight down from a helicopter. So the only one that actually makes sense with would be F. J almost works, except for that cylinder's inside, so you wouldn't be able to see it outside of the thing. Okay, problem 44 is the proportions that you guys keep getting stuck with. So we're going to go ahead and set up the proportion first. One of the fractions needs to be degrees. In this case, it's 120 over 360. The other fraction is going to be area, since this question is asking us for area. The really key important point is that you guys love to just stick that 3 there somewhere. The radius can never, ever, ever go by itself. It needs to go inside of a formula for these problems. So since it's asking for area, it's going to be pi r squared, and then we're looking for the part of that area. And in this case, the r, we know, happens to be 3, so I'm going to go ahead and just plug 3 in right there. So if I'm going to fix that circle part, the area. So we have x over 9 pi. 3 squared is 9. So we cross multiply. Remember, we're keeping the pi separate. We don't want to multiply that in. So 120 times 9 is 1080. And then this pi just comes along with it. And then 360 times x is just 360x. We're trying to get x by itself, so I'm going to divide both sides by 360. Remember, we're keeping the pi separate. So 1080 divided by 360 is 3. And so that would be the answer, is 3 pi. Okay, problem 45 is another proportion problem that you guys have trouble with. So one fraction is the degrees, so we're going to do, in this case, 45 over 360. And again, you guys love to just stick the radius somewhere. You can't stick the radius by itself. The radius has to go in a formula when you're doing these problems. So in this case, it's asking us for the length of arc JK, which is part of the perimeter, and so that's what I'm going to put in the denominator. It's 2 pi r, and in this case our r is 8. So I put that 8 into a formula, and then we're looking for the part of the circumference, so that's x. If we kind of simplify this a little bit, 2 times 8 is 16, so we can write it like that. So now we're going to cross multiply. I'm going to do the 45 and the 16 pi first. So we get 720 pi. Pi comes along for the ride. And then on the other side, it's 360x. We're going to divide both sides by 360. And so we get a total of 2 pi. So I only did 720 divided by 360, and the pi just comes along for the ride. And so that's our answer, 2 pi. Okay, problem 46. You guys see right away, I hope, that this angle here, this little sliver here, and this angle all come together to make a straight line. So that means that those three angles have to somehow add up to be 180 degrees. Okay, so let me erase the mess I made. Okay, so I'm going to set it up like this. Angle 1 plus angle 2 plus angle 3 is 180. That's an 8. It doesn't fit there. So angle 1 is this 4x minus 2. Angle 2 is going to be that little sliver of the x there. And then angle 3 is that 78 degrees. And those all have to add up to 180. So we'll go ahead and just start solving this out. We have 2x's. I'm sorry, that's not 2x's. Oh, how do I erase this? There we go. Okay, so we have, this is 4x's and that's 1x, so we have a total of 5x's. And then here we have negative 2 and positive 78, so that's going to give us 76. Okay, subtract 76 from both sides. We get 5x equals 104. And then if we divide both sides by 5, x equals 20.8. Okay, and so the question is asking us to find UTW. So UTW is this right here. Okay, so I'm going to do this one first, and we're just going to do it separately. So we have 4 times 20.8, which is our x, minus 2. And so you get 81.2 here. And then this one here would be 20.8. So we're going to add those together now. And you get 102 degrees. Now, here's the fun part. The way that I did it is technically the correct but long way to do it. If you're really thinking and you read the question ahead of time and really think about it, you're going to notice that UTW, this, is everything except for this 78 degree angle. And you know they have to add up to 180. So you could have just done 180 minus 78 equals 102, and you don't even have to bother with the x. Okay, so look for shortcuts like that, but if you need all the math, it's there to the right so you can see how to do it. Okay, problem number 47, we're trying to find zy, and so we do this problem where we make the right triangle here. This distance from u to y is the radius, which is the same as u to x. So 28 and 12, the total distance of our radius is 40. And so now we can just plug this in to the Pythagorean theorem to get that missing part. So A is going to be 12. We don't know B, that's what we're trying to figure out. And C is 40. So we have 144 plus B squared equals 1600. I'm subtracting 144 from both sides. So we get 1456. And then our last step is to take the square root, and we get b equals 38.16. Okay, and so that tells us that this is 38.16. We need the whole z to y though, so we need to double that, and we get as our answer 76.32. Okay, problem number 48. You see here that this angle right here is across from this semicircle arc. So since this is 180 degrees, then we know that this is 90 degrees. And so we're going to set that up as an equation and say 4z minus 10 equals 90. So now we just solve. So we add 10 to both sides. We have 4z equals 100. Divide both sides by 4, and we get z equals 25. And that's what the question is asking for, is z. So that's our answer. Okay, problem 49. It's asking for angle WTV, this angle right here. It's across from a 90-degree angle, so it means it has to be half of that. So it's 45 degrees, and that's our answer. Okay, problem 50, the very last problem, is an ice cream cone problem. We have this one and this one, so they have to be equal to each other, and we just set them equal. So we have 4x minus 2 equals 3x plus 3. Okay, it doesn't matter what we start with. I'm going to go ahead and start with the 3x, but you could start with something else and you get the same answer. So this is x, and on this side we get 3. I'm going to add 2 to both sides, so we get x equals 5, and it's asking for LM, so I need to go back and plug in. So 3 times 5 plus 3, we have 15 here, and when you add the 3 you get 18, and that would be your answer.